Hi, Honors Math 3. Today is Wednesday, April 1st. Happy April to everyone. I hope this finds you well and your family is doing well. I so wish we were together playing sticky ball, but this is the best we can do. So I asked you on your assignment today to work through numbers 1 through 7. So I'm kind of hoping that either on scratch paper or on this paper you already tried numbers 1 through 7. If you haven't, you might want to pause this, print them out, or grab some scratch paper and try. We're going to do half the review today, half the review tomorrow. I attached the 7-3 review assignment. My suggestion is odds tonight, evens tomorrow, just so you're practicing for 2 days. Alrighty, and we're going to have a nice little quest. I'm working on it on Friday. I've never done it on Canvas before, but it looks spectacular. And you'll have an hour to complete that quest on Friday. I left detailed descriptions of that on today's Canvas assignment. Alrighty, so again, hopefully you tried numbers 1 through 7. I'm just going to work through them in case you need any help or explanation or you want to check my work with yours. So let's see. I'm going to list the first 4 terms of the sequence. This is just a pattern. It's not arithmetic. It's not geometric. It's just a pattern of numbers. And I'm going to find the first 4 terms of that sequence. Remember, for a sequence, the subscript is your input. So for a sub 1, I plug in 1, 2 to the 1 minus 1 over 3 times 1 plus 2. And I get, what is that, 2 to the 0, which is 1 over 5. For a sub 2, I plug in 2, 2 to the 2 minus 1 over 3 times 2 plus 2. Oh, I forgot to plug in 2, which is 2 to the first over, what is that, 6 plus 2, which is 8, and I simplify and I get 1/4. When I find a sub 3, the third term, I plug in 3 as my input, 2 to the 3 minus 1 over 3 times 3 plus 2. I get 2 squared, which is 4 over 11. And my fourth term, I plug in 4 as my input, 2 to the 4 minus 1 all over 3 times 4 plus 2, what is that? 8 over 14, which reduces to 4/7. And those are the first 4 terms of that sequence. Alrighty, I'll write a formula for the general term a sub n for this sequence. Always check first with what we know. Is that arithmetic, geometric, or neither one? Is there a common difference between terms? Or is there a common ratio of terms? This is a huge decrease and then an increase, so it's not arithmetic. I'm cutting in half, cutting in half, cutting in half, and changing the sign. That means that there's a common ratio. -16 divided by 32, which is -1/2. And I get a common ratio of this geometric sequence of -1/2. Now you're asked to write a formula for the general term. The general term for a geometric sequence, a sub n, is always the first term times the common ratio to the n minus 1 power. Maybe a good idea today at the end of this video would be to list all of the formulas that we know so far. I think I'll do that, or that we would need to know for Friday's quest. So let's see, in this case, a sub n is the first term, which was 32, times the common ratio, -1/2, in parentheses, since that's negative, raised to the n minus 1 power. And that's it. That's a formula for the general term. Okay, for number 3, we do have some options here. Let's see, I'm going to find the sum, that sigma notation, for the terms from k equals 4 to 7, the 4th term through the 7th term of this pattern, -3k minus 1. I could use some properties because I can separate that subtraction. I can bring out that coefficient of -3, and there's a formula for the integers. The problem with using this formula is this doesn't start at 1, it starts at 4, so that's going to be a little bit tricky. And it'll be that j plus 1 and subtract what we didn't need, so that's going to be a little tricky. It is arithmetic because this thing is linear with a common difference of -3. So I could use the formula for the sum of an arithmetic sequence, but again, a little tricky because it's the 4th through the 7th term, so that gets a little tricky. Since it's such a short list of terms, I'm just going to list the terms and add them up, because I'm going to take the 4th term and add it to the 5th term, to the 6th term, add it to the 7th term, and remember my index is my input. So when I find that sum, I plug in 4. Negative 3 times 4 is negative 12. First term is negative 13. Plus, plug in 5. Negative 15 minus 1 is negative 16. For the sixth term, plug in 6, negative 18 minus 1, which is negative 19. For the seventh term, negative 21 minus 1, which is negative 22. I'm just going to list those 4 terms and add them up, and I got a sum of negative 70. Check with what you got and which method you used to find that. All right, again, we're going to work through number 7 today, and then tomorrow, make sure you try the rest, 8 through 13, and we'll do something similar tomorrow and see how you did. All righty, thanks for working through this on your own. I know it's not ideal, but thanks for stimulating your mind. List the first 4 terms of the sequence. Oh, it's a recursive sequence. So this tells us where to start and tells us how to find the next terms. First 4 terms, a sub 1, a sub 2, a sub 3, a sub 4. Well, it tells us where to start. A sub 1 is 8. A sub 2 says take the previous term, which is the first term, and subtract from it the index squared. My index is 2 squared. I get 8 minus 4, which is 4. To find the third term, I take the previous term, which is 4, that's the previous term, minus the index squared. What is that? 4 minus 9, and I get negative 5 for the third term. Fourth term, I take it's recursive, defined with the previous term, negative 5, minus the index squared, which is negative 5 minus 16, and I get negative 21. Alrighty, number 5, write a formula for the general term a sub n of this sequence. Okay, so this one we have to look for some sort of pattern. So when I plug in 1, I get positive 7 over 2 times 3. When my input is 2, I get negative 7 over 3 times 4. When I input 3, my fraction is positive over 4 times 5. When I input 4, I get negative 7 over 5 times 6. Here's my general term a sub n for that pattern. All right, to me, the denominator is a little bit easier to see. When I plug in 1, I get 2 times 3. Plug in 2, I get 3 times 4. So that first part of that denominator is the term number plus 1. The second part of that denominator is the term number plus 2. Make sure that checks out for this one. Yeah, that's a 2 plus 1, 2 plus 2, 3 plus 1, 3 plus 2. Then in the numerator, I know I want that 7, but notice it's an alternating sequence. Starts positive, then turns negative, positive, negative. Remember this trick? We use that negative 1 to some power. If I plug in the term number, that would be negative 1 to the first, which would be negative 1 times 7, which would be negative. I actually want it positive. If I plug in 2 to that second term, that would be negative 1 squared, which is positive, times 7 would be positive. I want it negative, so I actually want an n plus 1. Alrighty, there's typically different ways to write that. I don't know. Is there any other way we could write that? I don't know. Some people might have put that negative 1 to the n plus 1 out front times a fraction of 7 over, but I think we need that n plus 1 times n plus 2. So sometimes those sequences look a little different. Okay, let's look at number 6. This is a good one to remember some of those formulas we have, and I'm going to make a list before we end today of what formulas that you should be familiar with. So this is the sum of the first 4 terms of this sequence. There's a formula for, let's see, I'm going to take out the 6, the sum of k equals 1 to 4, the first 4 integers squared. There's a formula for this. The sum of the first however many integers squared is always n times n plus 1 times 2n plus 1 all over 6. Okay, so this becomes 6 times, I'm going to use that formula, but my n is 4. 6 times 4 times 4 plus 1 times 2 times 4 plus 1 all over 6. When I simplify, I get 4 times 5 times 9, which is 180. Using that formula for the sum of the squares, whoopsies, there it is, I get 180. So that's one of the formulas that we need to be familiar with. And last but not least, write a recursive definition for this sequence. Okay, recursive means tell me where to start. The first term is 11. And then for each subsequent term, define it in terms of the previous term. Okay, this is just kind of looking for that pattern. I add 8 to the first term. Can I add 8 to that term to get 35? No, it doesn't work. Can I double this thing? That'd be 22. No, that doesn't work. All right, so it takes a little playing around. Use this term to find the next term. Watch this. I can double the previous term, a sub n minus 1. So that'd be 22. What do I do to 22 to get 19? I'd have to subtract 3. Double 19. If I double 19, I get 38. What would I have to do to 38 to get 35? Subtract 3. And it works. And there's my pattern for that recursive sequence. All right, I'm going to turn this page over and I'm going to make a list of all the formulas that we should know. Okay, so this is everything that we should know so far. If you want to take a minute and try to jot these down, you can pause and see if you know them. We started with some formulas, the sum of the first n integers from 1 to n of k, which was n times n plus 1 over 2. I just think that's a good one for you to know. This one's a little bit complicated. Sum of the first n integers squared, that's the one we just used, which was n times n plus 1 times 2n plus 1 all over 6. The sum of the first n integers cubed, which looks very similar to this one, is just n times n plus 1 over 2, that whole fraction squared. All right, and then we moved on to arithmetic sequences. So these are formulas we need to know for arithmetic sequences when there's a common difference. And then there were some formulas that we needed to know for geometric sequences. Maybe you want to take a second and try to jot these down yourself. Geometric sequences when there is a common ratio. Arithmetic, we needed this one and this one. Geometric, we needed the general term, a sub n, the sum of a geometric sequence. That one was a little bit complicated. And then we saw a sum of an infinite geometric sequence. If we have not practiced these yet today, we'll practice them tomorrow. You have the whole sticky ball game, so if you want to practice those today, and then I'll just work through some tomorrow. Alrighty, so again, you might want to pause and jot these down. For an arithmetic sequence, the formula for the general term is the first term plus 1 less of those common differences, n minus 1 differences. The sum of an arithmetic sequence is n over 2 times the first plus the last. Formulas for geometric sequences. Pause and try to jot those down. The general term for a geometric sequence is the first term times r to the n minus 1. The sum of a geometric sequence was the first term times the ratio of 1 minus r to the n over 1 minus r. And if the common ratio is less than 1, then we can actually find the sum of the infinite geometric series, which is the first term over 1 minus r. Alrighty, we'll review those tomorrow. My suggestion is on the review for Mod 7, try the odds today. So then you're practicing 2 days, and the evens tomorrow, and you'll see what you need help with for tomorrow. And that will be due by midnight on Thursday. All right, thanks for checking with us, and have a good afternoon.